Welcome to my channel. Your tutor Mariam is here. It's the 12th video of Introductory Physics 1 and 8th video that I'm going to talk about the motion, which is the second subject of Introductory Physics 1. In this video, I'm going to solve the most common problem in the exam, which is about the y equation of motion in y-axis. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So this problem says a boy dropped a ball. A few seconds later, he dropped another ball. Both balls have the same masses and fall along the same vertical line. And the first part asks me what's the acceleration for both balls. So before I start this problem, let me remind you what's the equation of motion. In y-axis, these are the most common equation that you should use in your exam. And these are the same with the x-axis, and the things that's different here is the position and also acceleration. Let me remind you what's gonna be the equation 1 in x-axis as an example, which I mentioned in the previous video. So let me write it down in the x-axis. So in the x-axis, this equation gonna be changed to x equal to v naught equal to half of a t squared plus x naught, right? So here my g changed to 8 and also y changed to x, right? One thing I like you to remember from the previous video is g is equal to 9.8 meter per second squared, right? Or you might find it as a minus 9.8 m second squared, right? And this comes from the gravity. So this g or acceleration never change because gravity never change, right? Now let's go back to the problem. So the first part asks me the acceleration for both balls, right? So in this case, they both have the same masses, right? And then fall along the same vertical line, correct? So in this case, the acceleration for both of them gonna be g, which is 9.8 meter per second square, right? I would like to say it as a negative here. So, and then I can say they both have the same acceleration. So my answer gonna be the same, right? Because the gravity gonna be the same, and then it's gonna be minus 9.8 meter per second, right? Now let's go back to the second part. So which ball has the greatest speed? Of course, this problem doesn't give me the values for time, velocity, right? But let me assume some value here. So here I would like to use this equation, v equal to minus gt plus v naught, right? So let's see if it says in few seconds later, I would like to say this is gonna be t at 3 seconds, right? I'm just assuming some value, then I can explain it better, right? That's what I'm trying to do here. So now for the first ball, but I'm gonna write this equation, my v equal to minus gt, right? And I'm gonna say this v naught gonna be 0, right? And for the second ball, my v gonna be minus g and this t plus 3, right? So why I'm saying that, because if the first ball drop at t, the second ball gonna be drop at t plus 3, right? Now what I'm going to do is give the value to t. So I'm going to say, okay, it's drop as t equal to 1, right? I'm just assuming some value. So then for the first ball, my v gonna be minus g, right? And for the second ball, my v gonna be minus 4g, right? Let's call it as v1 and v2, right? Now I'm gonna give the value to g. So I'm gonna say my g is approximately equal to 10 meter per second square. I'm gonna substitute this value to my equation. So my v1 gonna be minus 10 meter per second, right? And my v2 gonna be minus 40 meter per second. So now answer is clear, right? v1 is greater than v2, right? Of course, you don't need to solve this problem because most of the time it's gonna show up in the multiple answer. But I just solve it to make it clear, and also if you have the problem like you don't know how to solve it, this is the best way. You can give them the value, substitute in the equation, and then it's gonna make your life a lot easier. Now let's look at the third part. So this part asks me, does the difference in their speed staying the same through the fall? Okay. So what I found in the previous slide is like my v1 is equal to minus gt, right? And my v2 is equal to minus gt plus 3, right? So the difference between speed means that v2 minus v1, correct? So I'm going to subtract them. My v2 is minus gt minus 3g, right, plus gt. These two cancel out, and then answer gonna be minus 3g, correct? So now I'm gonna substitute g here. So v2 minus v1 equal to minus 3. I'm going to say g is approximately equal to 10. So it's 10 and it's going to be minus 30, correct? So the speed, the difference between speed is going to be a constant number at a certain value. So it's going to be stay the same when the both ball fall, okay? So the answer is going to be yes, because I end up with a constant number, okay? Now let's look at the other parts. So this part wants me to see if the difference in their distance stay the same through the fall. So I think you already know the answer, but feel free to pause the video and solve the problem. So what I'm going to use is this equation. It's going to be gt squared plus vt plus y naught. This is for the first one, and for the second one I'm gonna go with this equation, right? The same one. So let me give them the 1 and then 1, this gonna be not, and then this gonna be 2, right? So based on what I assume, this gonna be 0, right? And also my initial velocity is 0, right? So the difference is going to be the difference between and y2 and y1, right? Let me write it down. y2 minus y1 equal to, and I'm going to assume that g going to be 10, okay? So then what I have is minus 5t2 minus, which is going to be plus 5t1 square, right? In the first slide, I assume that this few seconds later are going to be t equal to 3 seconds, right? Let me substitute this. So this is going to be minus 5t plus 3 seconds plus 5t, right? And this is going to be a square, correct? Now let me do some math here. So it's going to be minus 5t squared plus 9 plus 6t plus 5t squared, correct? Make it a little bit simpler. It's going to be 5t squared minus 45 minus 33 plus 5t2, which is equal to minus 33 minus 45, right? Because these two cancel out. So this is going to be the answer, but if you look at the answer, you will see it's not depend on the displacement or the position of the object, right? So if it's only depend on t and there is no x or y in this answer. So that means the difference, the displacement gonna be constant, and the answer is yes. I'm hoping solving this problem help you to understand this type of problems better and give you an idea how to solve this type of problem in the exam. If you like my video, hit the like button and subscribe. See you in the next video.